image, bringing it into life, right? So these are the practical examples of diffusion. So how it actually works, right? We write some algorithms, add noise to the data, and then reverse diffusion is where we remove it using algorithms, right? Instead of theoretically talking about all this, I'll just give you a good example here. Let us consider noise as something that is present in the world, right? Now you are talking about generative techniques, how to generate something out of noise. Let us call this mountain rock as noise. What was here before? I hope most of you would recognize this picture, Kailash temple, right? Ellora. So how was it created? If somebody is not aware, this was a rock, entire piece of rock to begin with. So they chiseled out all the rock, removed some pieces of rock, and left some piece of the same rock, which turned out into this beautiful temple here, architecture, right? This is a best example to show how denoising works, right? You started with a rock which you can call as a noise, remove unwanted material from that, and what remains is what you visualized in your mind, which is nothing but this temple. So I think most of the other temples you might have seen as bringing a stone to the temple, carving an idol out of it, carving carving gods images or idols out of it is one way of doing it, but this is what the perfect example of diffusion is. Okay, another example, all clay as a noise. Clay, when you look at it lying on the ground, right, it looks just like a piece of any other piece of clay. When you actually take the clay, mix right amount of water, stretch, mold, and bring it into a good shape, like image of Ganesha or here, what I'm showing here. This is what a diffusion means. Okay, I think these two examples give you a good picture of how diffusion works. Remove unwanted noise or unwanted data from what we are looking at and bringing a clear image of what we are visualizing. Okay. Now, what are the advantages of using this diffusion model? So as as we keep training this generative model, this keeps recognizing the noise or the unwanted data from it, and it results in high quality image generation. That's the end product, when we look at. Now, when we look at the other model, which we will get into shortly, right, GANs, this particular denoising is a stable way of training of generating images compared to GANs. But again, when we look at how we achieve this, so there's a lot of logic that goes into this. How do we remove unwanted noise? How to recognize noise? How to denoise that? So these are all computationally very challenging, and since because it involves complex logic here, it takes a lot more amount of time compared to GANs for generating the images. Okay, I'll quickly go to the GANs overview. Compared to diffusion model, how these work, right? I think I gave a brief example of a brief introduction of GANs in the previous topic. Looking at the definition, right? Adversarial network, generative adversarial network. This is, as I said earlier, adversary is an enemy, but here two sets of things work in tandem, while opposing each other. Their end aim is to generate a good output out of it, right? Here, when we talk about the adversaries, they are nothing but your generator and a discriminator, right? So here as the word itself suggests, generator generates images and discriminator tries to discriminate. What does it discriminate? Between real and fake. The generator tries to create some images, tries to pass it on as a real image. Now, the work of discriminator is to understand how real data looks like and how fake data looks like and try to distinguish between them and try to come up with a better end product as as the system keeps evolving, right? The end product becomes more and more better. So if you look at how this works, a visual example of this. Now let's call this person as a forger. Okay, he's trying to forge an image which was created by a well-known artist. Now you call this as generator. Now just take an example of a famous artist, Picasso, right? So this person, let us say, he's trying to copy Picasso's well-known works and try to forge them and try to sell it off as originals. Now, this guy who is looking with a magnifying glass here, right? He's nothing but your discriminator, right? So now this generator is trying to paint a lot of images or artworks and trying to pass it on as original. Whereas this guy, discriminator, he keeps looking at each and everything and tries to find fault somewhere or the other and tries to strike it off as a fake. So the more the generator tries to avoid the mistakes pointed out by the discriminator, it becomes more and more realistic in generating the images. And the more the discriminator learns how to distinguish between a real and a fake images. By the learning methods, this also becomes better over a period of time. This is how GANs fundamentals work. So as I said, it has two pieces. The generator, it converts the random noise into the data. Like for example, it gets the input, it tries to create an image of what was requested out of it, and the discriminator job is to identify whether the image given to it is a real or a fake. This is nothing but an iterative process of training where a generator keeps sending images and discriminator keeping trying to point out the mistakes in that, or how it is able to differentiate between real and fake, and taking that as an input to the generator, trying to make the outputs better and better. Okay. Now, when we look at this GANs and diffusion models, right? So as I said in the previous slide, right, diffusion model, it takes a good amount of logic and algorithms to make it better and better on how to denoise the things and come up with a better product. Here, when you look at GANs, right, the generation of images is very quick, and because of good algorithm that we put here in the diffusion model, the training that it gets is very stable. And in GANs, any misleading piece, because it's an iterative process, anywhere it goes wrong, the same thing keeps getting repeated, and the end it becomes exponential in the end product. That's the downside of GANs learning method. When it comes to the diffusion model, as I said, it takes a long amount of time to generate the images, but as the system gets evolved, right, it keeps throwing out better and better output, quality output. So this is what we discussed in the previous slide, as I said, right? So in GANs, as it tries to focus on certain areas, right, in the learning methodology, the diversity of it is lacking in the output here. And when it comes to training, right, the tuning is what is important. How to train your discriminator. What is the logic that goes into the discriminator in making the end product better and better? That is what the end result that depends upon the way it gets trained. And because of large inputs and iterative things, it is very resource intensive, because we need to provide more and more inputs for the system to learn and discriminate. It takes significant amount of resources. So we'll get to the practical examples of this diffusion models and AI images. So I'll just take you for a few more examples here on that. I'm sorry. I think the settings got reset. Please bear with me for a minute. Sorry, I was trying to enter some private information. Please don't mind. I've stopped sharing. I'm just resetting the configuration. Yeah, let me start sharing again. I'll give you the link of this website here. Just a minute. Can you see my screen now?
No, sir.
Not visible. Okay, 1 minute. Let me share again. Earlier, I was entering some personal information,
Yes, sir.
so I
Yes, sir.
stopped
Now it is
sharing.
okay.
Sorry about that. Yeah, I stopped it deliberately. Yeah, you can see it now, right? Okay. 1 minute. This is the site I was going to, right? Yeah. So here, these are again a few more tools, right, that we were discussing earlier. So can some, instead of me typing something here, I can type something and generate a video, but I just wanted somebody to give me a prompt here for any specific topic. Can I have some volunteer, please?
Sir,
Yes, please.
any topic you want?
Yeah, yes, please. Anything. This is
Natural
AI.
language processing.
Sorry?
Natural language processing.
No, we are trying to generate a video on a
Video,
given
video.
topic.
Okay.
Huh.
Sir, is it topic or place you want to that?
Anything you, up to you. I mean, just something that came to my mind. How?
Okay, sceneries in Andhra Pradesh.
Sorry. How?
Sceneries in Andhra.
Okay. Okay. I'll just say tourist or scenic places in. Okay, I'm just taking. Okay, it's just asking us what to use. Okay, I can
Okay, sir.
just take whatever prompt is. Again, as I have shown you in the tools, right? I have different options here. I can go to text to image, right? Now we are creating video. We can go to the new video section, put whatever settings we want. I just chose randomly an animation here, right? And it says Discover Andhra Pradesh. See, it has given the title on its own. If you remember, I never typed the word discover, right? I just said tourist or scenic places in Andhra Pradesh, right? Now it has given a title Discover Andhra Pradesh, and it asked which technique you should use. It said claymation, animation with clay modeling kind of image, right? So which is claymation. So it has put the title on its own. Now it's trying to generate an image here. So end of this session, right? I'll probably send to Kameshwar Garu on how to uh, give tools based on sorry. 1 minute. Or I think I gave Satya. I did not watch this. What I was selecting. I think I chose the wrong one, a paid version. But again, I'll give you the tools that use different models, so you can get an understanding of how they have. 1 minute. Let me choose the right model here. I'm just using whatever is already there is generated in stock, right? I'm not sure. Sometimes Teams plays the audio or not over this meetings. But if you try to do it on your own, sometimes it might send the music as well. Let me try that option and see. I'll try to play this end of this demo. The second thing is I'll give you various tools that are based on different generative models. Which ones? I think the stable diffusion, the one I showed you earlier. This AI.in video is something I showed you. I just sent the link to you. Again, there is one more, which I will come to this shortly. Okay. Now, once you look at all these things, you can appreciate how each of these worked. Sorry, I think I gave a partial URL. Sorry, let me give that again. Please bear, it would take a few minutes. So when I give those live examples of the tools, right, you can understand based on which model that tool has evolved and how the output is. You can always compare and contrast between two methods. Okay, how the diffusion model works, how the GANs work, and how the output is. Obviously, each of it has its own strengths and weaknesses. In the meantime, I have given the link. You can try something on your own. We can create educational videos, like, for example, how a chip works, a transistor works, or internal workings of a CPU. We can create educational videos like this, or how does an internal combustion engine work, an animation video of it. Right, let it. So again, you know, this has multiple examples, right? Sky is the limit for this, if we should say. It all depends on the creativity of our own. Mainly because I'm talking to eminent lecturers and professors here, I am restricting most of the topics to education field itself. So yeah, obviously, yes, sir. We are using our personal computers, and it's not a commercial application, right? We are also on the free tool, not a paid tool. Obviously, the features we get are also limited. I think it's almost done. Pardon me for that. But then again, when you use high-end computational systems, right, which are for commercial purposes, these things will be done much more quicker. Once you get this, I'll play it, but this MS Teams is a little bit trickier thing. Sometimes the audio comes on the calls and sometimes it doesn't. But then again, when you try on your own, you might be able to appreciate the audio as well. Okay, again, there are other tools. Let me send those links to you. These are various tools that you can keep trying. I think I gave this URL already. So while this image is getting generated, right? So here I have given the URL for this runway, right? Here we have multiple options here, right? You give a prompt and generate audio. This is the text to speech or TTS, what we call, right? Very much, we are very much familiar with this. You give IVR systems a prompt, right? You tell what to announce and it does that. This is, most of us are familiar with this. And this is a lip sync video. You can just try this as an example. So you drag and drop one video here, okay, which has an example scene. Like, for example, if you're interested in a movie, right, you can create a scene of it and maybe a song out of it and lip sync with you with your own image, which shows as if you are singing that song, right? I think this is taking a while to generate these images. That's why I'm not trying those examples, but this is just one example of it. And this is, we can try with all these things. Remove the background. Okay, I'll show you one quick non-video example for you after a couple of categories here, because videos are taking a very long time. So this is something where we can take a video and let's say I want to remove the trees from this image. We have people here. Probably one of the trees is blocking one of your friend in the video. You can remove that and regenerate the video, right? A text to image is something that we have already seen, right? You type a prompt, it comes up with the text. So I'm just trying to create image to image. So what I did earlier, I'll just take one small example. Okay. We created this earlier, right? Videos are anyway a little time taking. So let's just use one of the images and do a quick demo of this. I think it has failed. So here I'm just, I hope you can see my screen where I'm typing it here, right? I'm just typing, giving an example here, add a beach chair to my original image. Okay, here just this is the view of a beach, right? I'm just doing this. You can see by the way the system has evolved so far, the kind of images it is producing. These have not evolved so much so far, as you can see from the output once we get it. You see, this is coming. In the meantime, you can also open these sites and try something on your own. Looks like there's a problem with this. Yeah, you see, I just asked this to add chairs to this. I don't know what kind of chairs it has added. So this is the way it has evolved so far. Again, there are other views, other features on this website which I used earlier, but somehow today the network is very slow. I didn't want to waste the time, you know, working on this. But again, I was just giving you the examples of how these things work, what each of them mean. Okay. And this is what we were talking about, erase and replace. Like for example, in a given image or video, you can remove a person and add somebody else, change the backgrounds. Okay. This is a 3D capture of a 2D image, giving a 3D textures for some animation videos. Like these are some kind of educational videos. Obviously, I tried them, but they are really time taking. That's why I'm not giving the demos of these things. Okay, create a normal speed video into a slow motion video. I think somebody who's using an iPhone already has this feature inbuilt in the camera itself, right? You can capture a slow-mo video, right? Even though you record it in the real time, the output is in a slow motion. In blurring the face, right? We have a number of features available on this website. You can keep trying them. As you have seen, this is very fairly, interactive to use and very easy. All you have is quick prompts here. It just asks for you to give the original image or original video file, and then uh, you can upload an audio and sync. For example, you can put your own video, your own image here, right? Play a song and make it lip sync to that song, which will make it look like you are singing that song, and will create an animated video out of it. Okay. Again, this is another site which I have given the link for. Okay. Again, you can play around with this using different features here. You can create avatars of you, and you can add backgrounds, various backgrounds here, nature, animals. So you can add a number of features here. And the best part of it is with when you go for a full premium subscription to this, you can create a video, you can create your own voiceover, remix with background music, all that, all within this website for a paid subscription. Okay. So again, going to the generative AI tools, right? Now we have been discussing, different examples of real life applications. So keeping our, area of discussion to education, right? We can use this generative AI for various educational videos, images so far, and we can make use of what works better. See, some areas diffusion model works better by denoising the things and creating the images, whereas some require iterative tools, right? Iterative methodologies like GANs, right? Which come and refine the things over and over. Like for example, you don't have an existing image of something, right? That is where you can think of giving more and more prompts and coming up with a refined prompt, which will come bring your output close and close to what you want. So this is an iterative feature. And when we integrate all this, sometimes it comes with a better processing and a better output, because you have all the features here. But then again, the downfall of it is it doesn't work because it is still evolving. It doesn't work in certain conditions, right? For example, the earlier we tried certain things, it didn't work because it does not have stock images, or it has not encountered a certain request earlier. It is still in the evolving process. We might have to go back to the generative models again and probably give better inputs to that and let it come with the output that we want. Okay. And again, as we discussed, ethical consideration is one thing. How do we avoid the misuse of these tools here? Okay. So we wanted to cover more examples, but unfortunately things are not working here. I will try it one more time. Obviously, if I show you the final output, it doesn't make sense. That was the reason I was trying with a live demo. Unfortunately, it's not working at this time. It has become very slow. Sorry, earlier, so maybe it's not working here now, but earlier what I did was I did two things. One is created a video out of a prompt. Then I started adding more and more prompts here, like the way I showed you in this photo, right? The other website, right? Some of the websites are coming up with better outputs as and when we add more prompts to that and refine. And in some areas, when it doesn't work with the prompts we are giving, it's always better to go for uh, you know a prompt that comes out of existing AI, like a Microsoft Copilot or a Gemini tool. Asking it to generate a prompt for us and using that prompt to request an AI tool to generate a certain image or a video. Sorry, obviously these video features are working very slow here today, but at least you can all play around with these tools and come up with your own creative ideas and start generating them. So combined topic, those are what we had for the session. I had for the session today, and I'll be sharing with you some references as well as some tools that are made based on different generative models. Okay. Anything else that you would like to discuss?
Please.
Sorry, somebody was saying something. It stopped in between.
I request the participants, if you have any queries, you can ask Rajesh sir. He will explain anything you want.
Sir, let me quickly go through the messages here. Yeah, in case somebody has typed
Okay, sir.
something.
Okay.
Yeah, yeah, Vijay madam. Yeah, you can prompt it for a specific topic and it can create for the sake of fun, right? We in the initial days of exploring these tools, right? We were checking out with creating a greeting card, for example, right? Anniversary wishes, so on. I mean, that was some simple thing that we did here. Generate a beautiful message for somebody's, 25th wedding anniversary, and using some of the prompts, we created a greeting card as well. And on the same lines, we asked the tools to create some, give us some insight on a certain topic. It was giving good amount of information here. Probably, yes, you're right. So really help with that. And again, there is no limit to what we do here, right? We can use our creativity, give some prompts here. The right amount of prompts will give you the right text output as well as demo images, right? You can always ask it to create some demonstrative pictures and you can combine both of those texts and images, and which will add more value to the book, the output. Moving on, Padmarao sir, yes. I have tested this in a different network where the speed was good. So the videos were loading very quickly. Unfortunately, even my network seemed to be very slow here today at home, and it's taking a very long time. But yeah, again, other limits are that we are using some the hardware that we are using, right? We are using our personal laptops, but if we use high-end machines, right, with good processors and all this, the output will be very quicker comparatively. By the way, I created a video. Unfortunately, I didn't download. Like I was discussing with some on some academic videos earlier. I think I mentioned the same. We created a small video on workings of an internal combustion engine with one of my mechanical engineer friend, and the output was very decent. What we got. So moving on, I can give some, now that we have a little more amount of time, uh, practical applications of this is, uh, maybe some of you are aware of check fraud and all that, right? Again, we are trying to inculcate with some of the industries on how to identify the real checks. Again, in US, some of you may be aware of this already. There is a check scanning software used where it scans the check instead of presenting the physical check to the bank. We're trying to use some AI features there, although I'll not be able to disclose that with the larger audience here. We are trying to enforce some security features into that, which will make sure that the original check only passes, not the fake checks. One more practical example that I could give you. We were even, of course, this might also fall into the category of OCR, optical character recognition. Uh, the same software we were using it for recognizing the handwritten amounts, dates, signatures, etc. Sorry. Yeah, those are some of the we were trying to combine various features that we already know of into this. Like OCR is something we already know, right? How to better use that with this kind of security features to make sure manual intervention is not required when we have to clear large number of checks, right, for an institution. Handwritten check also should pass through. We're working on those kind of techniques here for some of our customers. So those are some live practical examples that I could give off from my personal experience. So any other questions that you have?
Dear participants, any other questions? If anybody having any questions, you can unmute yourself and ask the questions. So Rajesh sir.
So I will pass on some websites, reference material to Kameswara sir. Request you to share it with everybody, sir.
Yes sir, yes sir. I'll share that one.
Okay, sir. Sir, if there are no further questions, can we close the session, sir?
Yes sir, if nobody asks any questions, we'll wind off the session within 2 minutes, sir.
Sure, sir. We will wait till 4:30. Let me see if any of these come up with some output. Can probably do a demo again.
In video, I have created Rajwada indoors video.
Sorry, ma'am. I couldn't
I
get
have
you.
got an output over here in this in video.
You want to share it here, ma'am?
No, actually, it's not supporting the Chrome over here, but the content is being shown over here as of I have created.
Okay, ma'am. I
It's
think this
asking
could
for the
be in
Chrome.
a stock image. I'm taking this as a simple example here. Let me see if it will generate a video here. This could be one of the stock videos it could have. That's why it could come up quickly than what we typed earlier. Because we tried it earlier, I thought it would have saved it. Let me come to the home page again. You must have seen a lot of demo educational videos, but again, playing whatever I have already saved will not make any sense unless I show you this live here. Let me try to take something with a very simple requirement. Uh, Create a video. Just take some something that is very simple. Let's try that. I know it's not a very creative video, but at least it will save the generation time here. We tried this already. Text to image. Sir. If anyone would like to demo that video that they were able to successfully generate, yeah, we can probably check this out here. Would you like to share your screen?
Sure, sir.
Madam, just tell me your name, then I'll give the presenter option, then you can share the screen.
Okay, my name is Devopriya Ghosh.
I just tried to generate a simple video here. Let's see if it comes out. In the meantime, we can watch Devapriya Madam's video.
And now you are the presenter, you can share the screen.
Sir, may I know is my screen is visible?
Yes, ma'am. Yes, ma'am.
In just 60 seconds. First up, we've got this guy's like the traffic cop directing the flow of data and instructions. Think of it as the part that tells everything else what to do and when to do it. Next, the or arithmetic logic unit. This is where the magic happens. It handles all the calculations and logical operations your computer needs to function. Basically, it's doing the math behind the scenes. Moving on, these are super fast storage locations within the CPU. Think of them as the CPU's notepad, holding data that's being used right now. Quick access, quick storage, quick retrieval. Then we have this is your CPU's own little stash of memory designed to speed things up. It stores frequently accessed data and instructions, so the CPU doesn't have to go all the way to the main RAM every time. Faster access equals faster performance. And finally, these are the data highways that connect all these components. They carry data, instructions, and electrical power between different parts of the CPU and other components of the computer. No buses, no communication. So, there you have it. The control unit, ALU, registers, cache memory, and buses. Together they make your CPU the powerful engine driving your computer. I hope this quick breakdown helps you understand what's inside that chip. Catch you next time.
Thank you, ma'am. As you have seen, it is showing the images of everything close so that we can get a good understanding of how things work, right? Within the CPU. Yeah, that was one example I gave. Thank you for trying the same. In fact, when we learned about the AI tools, we did some demo videos. Of course, we did not save them. Working off, for professors from electronics background, we can talk about gates, circuits, how things work, transistors, ICs. We created small demo videos of all those. Of course, in our industry, we have people from various backgrounds, various engineering backgrounds. We created small videos of each and everything, and uh, these days we all have good facilities in our colleges with digital classrooms. We can make use of these tools to show certain topics look very dry, if I should say, rather than teaching a lot of theory on that. It makes sense to use these kind of practical videos. This approach will make it very interesting for the students, as well as the understanding will be much better than what we read it in the textbooks. Again, certain good features that I talked about in the live things that we are doing for our customers. Due to confidentiality, we cannot show, but again, those are very good examples that we could we created and developed on our own. These are not a stock images or whatever we have. Of course, these were again made using images. That was the reason I brought these two examples into the discussion here today. One was about the checks. The second one was about facial recognition that I talked about earlier. Unauthorized access, where we are trying to identify the person and throw an alert that some breach has happened in your physical security. Yeah, the applications are endless. As in, no, more and more we think about it.
Participants, is there any other queries? Thank you, Rajesh Garu, for giving very good insights on computer vision, image generation, and diffusion models and GENAI, GENs. And we are very happy to be given a very good session to us. And thank you very much for Umadev sir to providing very good speakers for these sessions. Thank you, Rajesh Garu. Thank you.
Thank you, Kamesh Garu, for the opportunity as well.
Rajesh Garu, if you nobody is giving any asking any queries, then you can leave, sir.
Thank you, sir. Uma is also here with me.
Thank you,
Yes, sir,
Kamesh
yes, sir.
sir. Thank you, Shiv Shankar sir, for this wonderful FDP and organizing it so well, sir, and giving all of us opportunities.
Thank you, sir. Thank you very much, Umadev sir, for providing such good speakers from India and outside the India also, and the sessions very well.
Kamesh sir, thank you for giving the opportunity. This is Rajesh here, and I feel honored to speak to a lot of learned professors here. And if you find that any beneficial, I'll be sharing more reference points and tools with all of you. So thank you. Please pass on your feedback if you have anything for me as well. Thank you.
Yes, sir. Thank you very much for all the alumni of SRKR. Doing very good job for giving service to our people. Thank you, sir. Thank you very much. Sir Rajesh sir, you can leave, sir. No problem. We will
Thank you,
continue
sir.
for tomorrow.
Thank you, sir.
Okay, thank you, sir.
And have a
Thank you,
nice
sir.
day to
Thank you,
everyone.
Umadev sir.
Sure.
Thank you, sir.